Okay, we're going to get started now. We have a presentation by Ash Dalal, who has done a tremendous amount of work across a very broad spectrum of everything associated with electric vehicles and electrical systems in conventional vehicles. He's largely responsible, or has a very big responsibility for that lowrider EV setup that's over there, which you're not allowed to go look at, but you can sort of see it in the distance. And he's worked on everything imaginable. He has a dyno over in Dixon, and he does EV upgrades to if you got a worn out gasoline car, he'll upgrade it into be a battery electric car. He's an expert across the spectrum, can do just about anything. And you also were a student of Larry, Dr. Frank, right? So he was the father of the electric hybrid vehicle out of UC Davis from 25, 30 years ago, 50 years ago, and Ash trained under him. So we're very lucky to have him here to do this presentation. So please help me give a warm welcome to Ash Dalal.
Thank you for the introduction, Tim. First off, I want to thank Tim and Gina and Marissa for putting this all together. I think it's great to have the involvement of fleets and the community to really bring up the technology, but it also show the benefits of this. But in order to do so, we have to be safe about it, and we have to kind of train ourselves now for this new revolution of energy sources. And so today, hopefully we'll discuss some of that. So if I can go to the next slide, please. So yeah, I'll get a little background on myself, and then we'll hopefully start talking about understanding some of these risks. In this room alone or outside, we have multiple displays of different technologies, different ways of moving people from one place to the next. We had a discussion panel here with propane. Meanwhile, I'm looking at battery electrics. We still have diesels, gasoline cars. Everything now is available to us as a form of transportation. So we're going to understand some of these risks briefly, and then try to figure out how to mitigate some of these risks, and then open it up for Q&A afterwards. Let me go to the next slide, please. So just a little bit more background on myself. Like Tim mentioned, I've been in the game for about more than 25 years, and so lost every hair up here, turned everyone over here gray. So with that, I'm hopefully going to provide engineering services from engineering itself all the way to product maturation, training. I am one of the trainers here at Cal Epic, as well as one of the engineering foremans for companies who come in for any support of some sort. So happy to help with anybody afterwards and discuss those details afterwards. But if you want to go to the next slide, please. So we're going to kick things off with the mutual understanding of energy. What we do every single day revolves around the food we eat, the energy that we absorb during the day from the foods we eat, the things we drink. So as a energy storage device as myself, I try to take care of myself sometimes with the right foods and the right types of containment of those energy sources. I don't want to keep my milk out in the open when it's hot. I don't want to keep my ice cream when it's hot outside, healthy ice cream. So a lot of these care tactics are now necessary for the energy sources that I'm consuming, right? It's just the same for your car. So if we want to move to the next slide here, we have to understand that stored energy is technology agnostic. Whether it's a battery, whether it's fuel, whether it's propane, we're storing it, and that has the potential to release itself and cause problems to not only your staff, the facility, but your equipment as well too. Just as a frame of reference, people need to understand also a gallon of gas, which we've all had used to now for hundreds of years, is equivalent to about 33 or 34 kilowatt hours. And so if I think about that more, what is 33 kilowatt hours? Well, a Model S, 100 kilowatt hours, that's about 3 gallons of gas. These cars are about 150 kilowatt hours, and so now you're talking about 5 gallons of gas. Would I treat 5 gallons of gas any differently than an ounce of gas or any other equivalent amount of gasoline? Probably not, right? The effects of it are just as detrimental as it is 5 gallons versus 1 ounce. Very flammable, very toxic. I can inhale it and get really, kind of asphyxiated from that too. So if you think about that frame of reference, 33 kilowatt hours is about a gallon of gasoline. If I had a beer bottle's worth of gasoline, that's about 4 kilowatt hours. Again, a beer bottle's worth of gasoline on the floor next to an ignited source or any sort of heat source is just as bad as a battery of that same capacity. So think about that and keep that metric in your head. 1 gallon of gas, about 33 kilowatt hours of energy. Again, this is the potential for release. Go to the next slide, please. So we're going to now kind of separate the different types of energy sources that are now problematic, but also ones that you need to prepare for in your facility. So we'll start off with the big picture of looking at how we contain and how do we maintain these stored energy sources in our facilities. So we'll start off with internal combustion. Normally, we would have our containers of gasoline, our little crates of oil. My buddy changed his oil the other day, so I have a little canister that just says oil on it. I might have a drip tray or two just to put everything on. All great if I was a onesie, twosie kind of garage where I only had maybe one car, not too many people walking around. But in reality, every single one of those items has risk. The gasoline, explosive. The oil, very corrosive. The coolant, not flammable, but still I can ingest it. I can get hurt from it. I can still get insects in it. There's a lot of different characteristics that every one of these fluids has that poses a risk. Drip tray, probably not going to help you in a lot of these big cases here. So if I go to the next slide, that's a no-no. If you are a fleet, if you are under any observation from any state organization or any rule or regulation, that won't work for you from a safety standpoint as well as from a logistics standpoint. It's just not preparedness for the potential risk that can happen from these energy sources. And so instead of a drip tray, we now have a flammables cabinet, right? We store these fluids, these containment things in devices now that can contain if anything does happen. Let's say the gasoline gets hot, we now have a way to contain that explosion of sorts in these flammables cabinets. So again, we've already prepared for this storage of energy in our current state with a flammables cabinet. Check. Now we have that solved. EVs, for instance, now, if you want to move to the next slide, do we just stack batteries on top of each other? No, right? Because it's the same risk. Instead of me holding a gas tank of gasoline, now I have a battery pack storing that same amount of energy just in a different form factor. So when we think about maintenance, when you think about safety, most fleets may not be fully responsible for taking batteries out or handling a lot of these energy storage devices. You may have some relationship with the dealership or whoever you lease the vehicle from to service that. That's all well and good, but you still need to consider the safety implications of storing batteries. So in this case, you wouldn't normally just stack batteries in a corner and hope no one goes over there. Instead, if you want to go to the next slide, please, we now go to the next slide again. A new form of containment now that is recommended for batteries, and that is a temperature controlled environment that now has the ability to modulate and protect, and just like the flammables cabinet, prevent any incident from happening. We have an example out back that I'll happy to show you in one of our breaks. But again, if you plan on working with technology like this with energy sources, no matter what size it is, again, keeping that metric of what equivalent energy that has in gasoline, I want to protect myself as well as my staff, as well as my equipment. We have to also consider the amount of money that is responsible for purchasing this equipment, again, is not cheap. I'm not going to lie. But what's the cost of a lawsuit? Again, there's a little bit of a difference here, a little bit of preparedness. So if you anticipate working with these type of technologies, especially with a blend of technologies where I have propane, hydrogen, and battery, again, these are now the necessary steps you need to prepare your facility for safety. If we now look at hydrogen, now I've got pressurized cylinders. Instead of electrical fuel, now I have a chemical fuel now that it's in a high pressure, very volatile cylinder now that's sensitive to temperature, sensitive to physical characteristics. I can't kick it, I can't drop it, I can't roll it. It has to be contained, otherwise it will rupture and cause a safety risk. So instead of having loose bottles floating around, I want to go to the next slide, please. I now have a recommended area in my facility to store this energy where I now have proper signage, I have proper labeling, I have retention. So in any case we have a earthquake or any sort of natural disaster here, those bottles are now protected and away from everybody else. So again, we have started our thought process now to create these safety environments now around this technology. As much as the industry is very reactive in coming up with the right strategies, right training, right equipment, we still have this challenge of, hey, this technology is here right now and we have to do something about it. There are tools and methods to protect yourself as well as your staff. You just have to go do that extra step to now understand what resources you have, what technology you're playing with, and then follow suit with the correct safety there. So at the facility level, again, we now have the ability to select and purchase this if you do plan on having this in your fleet for the long haul. Go to the next slide. So now let's focus on the employee themselves. And so the employee themselves is now confronting this technology at the micro level. So instead of the logistics and the facility, now I have to focus on the technology itself. What we're used to is our traditional internal combustion engine vehicle, where we have a gasoline or a diesel engine that is hot, that has a bunch of oil, a bunch of dirt, a bunch of things I can physically see that I can prevent myself from either touching or exposing myself from. The gas tank, exactly the same thing. It's a vessel that is now containing this energy. So we know how to protect ourselves. If you go to the next slide, if we have our stored energy risks, which are, again, the fluids and the containment of those fluids, whether it's the gasoline or even the coolant, the impact of that is irritation to our skin, our eyes, respiratory. A lot of the things that can now impact us on a day-to-day basis can easily do so with some of these fluids. That is now our embedded risk. How do we mitigate that? Personal protective equipment and training. We have to make sure that training and compliance is issued to people periodically to make sure that they're up to speed and they're aware of what the consequences are, but also understand what tools and resources the companies now have to protect those employees. And so PPE and training are very important. But again, we're used to this. This is something new. It's not something new. This is something that we've had now done for the last 100 years for the internal combustion engine. So if you now migrate to the EV world, if you go to the next slide, please. The stored energy in this case isn't a fuel tank. It is now a stored electric fuel. So these battery packs are much larger. They're much more dense. They don't carry as much energy as a gallon of fuel per se, or a tank of fuel, but it is still a form of energy now that releases itself in a form that's invisible. If I see oil on the ground, I can simply avoid it. I can clean it up. I can prepare for it. If I have an exposed conductor or something that is in a battery that is now able for me to look at or even come close to, I can get shocked from it 10 feet away. So again, the risks are now have to be understood by not only employees, but the people around you. It's not my responsibility to take care of everybody else, but now it is. I have to now prepare myself, the world around me, and execute my work safely and diligently with the right amount of equipment. So when you're dealing with batteries now, you now have to prepare yourself with additional PPE that might be necessary. And again, this may not be your responsibility. As a fleet owner, you might have a service that comes in, or you may have an operator or a company that now deals with this. But if they are coming to your facility, you still have to provide them with that safety, and you also now need to make sure that they don't, get hurt themselves. I have some examples of some PPE I can show you afterwards, but again, a whole new realm of equipment now that I need to prepare myself for that isn't the same as what we're used to. No more little rubber gloves, no more goggles. Now we have a lot more robust hardware now to protect ourselves from what we call arc flash, which is this incident where the energized battery can easily shock me even from 10 feet away sometimes. So PPE, again, personal protective equipment, very much necessary, as well as this ongoing training is very much crucial to the success of your business as well as the use of these products. Go to the next slide. Next one again. And if we now talk about the safety implications around hydrogen, now we're introducing not only a battery, we're not only introducing a motor, but now we're introducing, again, those pressurized safety vessels. And so if I have those vessels now containing hydrogen at high pressures on hot days like this, we have to be aware of what those systems can do in situations like this. The world has realized that over the last 100 years of automotive development, people have gotten hurt, people have gotten into accidents. Hey, temperatures get hot, they get cold. The industry has evolved and accumulated all this knowledge and has executed with the right safety on this equipment. So feel assured that what is on these vehicles is safe to be on the road, but it also requires you to be diligent enough to make sure that those processes and those methods are retained. So in this case, you will have valves that will release the gas if it overpressurizes. You will have meters that will tell you certain things to be aware of, like pressures and humidity, things in that sense. So always work with that manufacturer, always work with that company that is supplying with those products to make sure that you are both on the same page. I might not have the responsibility of touching it, but I do have the responsibility of making sure that it works on a day-to-day basis. And so you may have to incorporate additional inspection procedures. You may have to incorporate some additional work to, again, accommodate this technology, but again, think about it from a safety standpoint. So hydrogen, again, now I have a stored energy from the battery, stored energy from the hydrogen itself, as well as the containment of fluids and such that are already on the vehicle. Go to the next slide, please. And so, kind of as a summary now, if we take a look at what we need to do to mitigate all of these risks from a facility, there is always a specific application for your product that also needs to be understood by not only the employees and the facility people, but from the product companies themselves. Amazon, for instance, has these Rivian vans that are meant to now be delivering packages day to day, stop by stop. Well, let's say Amazon says, well, Rivian, now you can sell these to the general public. Now this becomes a, off-grid camping vehicle. So again, the intentions of that vehicle, the application of the vehicle is different. If I was now servicing that vehicle, I would have to know that to make sure that what I'm doing, what I'm changing won't affect the performance of that vehicle in the long haul. So every vehicle will have its intended application, but unless that customer knows how that vehicle is being used, and as well as the supplier, again, everyone has to be on the same page to make sure I'm servicing it correctly and I'm using it correctly. And so that includes the industry-specific training. Personal protective equipment, again, understanding what resources you have and what technology you're dealing with, there's always a method for making sure that you have a safe and operating environment there to equip yourself and to provide this continual training effort. One thing I also recommend doing is, if you are incorporating this technology, is to have somebody dedicated to become the safety coordinator, performing these operations, performing these checks, making sure that everyone's up to speed on training. Again, these are the necessary steps now to make sure that the technology works for you, not against you. If we go down to the next slide and now talk about the vehicle, one of the important details that I think was discussed earlier is the fact that these vehicles now produce data. They are now capturing a lot of this information as you're driving mile to mile. Battery voltages, temperatures, all of the sense. That information is stored in some cases. Hey, why not have it? Why not I have this information at my dispense where that safety coordinator can also perform these inspections possibly to make sure that the vehicle is safe and operable. A lot of these vehicles now broadcast this data over the air. If they can read it, why can't I? So again, you have access to that information. Ask that operator, ask that company if I can have access to that too, so I can observe if there's anything else wrong with the vehicle that I can service ahead of time. Alongside that too is a lot of the software and a lot of the hardware to connect to that vehicle that is also specific sometimes. And so it's always good to make sure that you have that ability to access that, and you do have the ability to use it correctly for your benefit of understanding the performance of the vehicle as well as any safety implications. And lastly, high voltage safety training. As much as we rely on the utility industry for those facts, the automotive sense now has the same restrictions and same risks, but a different application. Can anybody tell me what is the commercial interpretation of what is considered high voltage? If anybody can raise their hand and tell me what is considered high voltage in a commercial building or any facility. If anybody can. All right, well, think about 480 volts AC. That's really what's considered high voltage in the commercial world, in buildings, commercial venues like this. In the automotive sense, it's 50 volts DC. So completely different, much more strict. 50 volts compared to 480 volts. Again, if I don't understand my application, if I don't understand my use case, I may walk into a 300 volt battery pack thinking, oh, that's not 480, I'm good, I don't need to prepare myself. That is entirely wrong. Again, that's where you need to understand your application, understand your use case, but also understand, am I dealing with a panel? Am I dealing with a battery pack? Again, both do different forms of energy sources there. So that is pretty much the summary. Any questions? Yeah. Yeah, so the question was, do you have any personal protective equipment for battery fires? And yes, there are. I have an example over there that is one that is a blanket now that is offered in multiple sizes, from small, like maybe small footprints like this, all the way to car size, and they even have ones like the size of a house. The goal for those blankets isn't to put out the fire, it's just to contain it. So know that they are still the potential for that fire to be disruptive once that blanket's removed. But all that blanket is doing is removing the oxygen until you have, first aid or some fire protection coming in your service. So there are some high voltage blankets, let's say, that will now protect you from isolating the heat, but they will not put out the fire. They will just contain it. But yeah, there are some options there. I'll be happy to show you afterwards. Any other questions? Early lunch? All right. Yeah. That's a great question. So the question was, is this PPE, the personal protective equipment, available to the general public? Yes, it is. I'm a single person that was able to buy it. The only thing you would have to consider again is the budget. They are on the expensive side. So if you anticipate doing this work frequently, for me, if you're going to be doing an operation more than once, better to buy the tool. I just like buying tools, so I just bought it anyway. But in any case, if you do plan on doing this work, there are certain options that you may or may not need. That little orange case, for instance, is a high voltage tool set. So if I know I'm going to be operating on equipment that is energized at one point, but again, isolated to a specific energy source, like inside of a battery pack, there's tools for that. Do you really need that? That's again up to your operations. If I'm at that level of service, yes, I do. But if this is at home, yeah, there are some small things that you can purchase, like those blankets as well. So yeah, we can certainly make those recommendations. There are a couple of suppliers that are out there that I can happy to help you find out. But on top of that too, depending on the type of equipment that you have, also recognize that some of them may need certifications. And so, for instance, your high voltage gloves, again, were meant for the utility industry, not for the automotive industry, but they still require inspections every 6 months. And so in that case, I'd have to buy two pairs, so I don't have time lost, when that time the other ones are getting recertified. So, but happy to share some resources for you. Mm-hmm. Perfect. Yeah, and that's also a great point. A lot of the infrastructure that's based around solar that is now bringing in these batteries into your home, they do a really good job of selling it to you, but that's about it, right? They don't. Once that transaction's done, your name is signed, they're off to the next house. So that poses a challenge, not a risk, but a challenge for homeowners like yourselves to say, well, what happens in these situations? That's certainly a discussion that we can have, but at the same time, there are some kind of small items like the blankets and things that you can prepare for, but it's also understanding your resources that are embedded into your house, knowing where your circuit panels are, knowing where a lot of the safety is already embedded. So hopefully, if everything was permitted correctly and installed correctly, you should have most of that in place. It's really just an understanding the sequence of how to properly discharge, those devices. Any other questions? Yeah. Yeah, so Tim brought up a good point about training for safety and technicians. And again, we're in a space now where everybody has their own secret sauce. Rivian has their way of controlling batteries, Tesla has their way of charging things. We don't know exactly what the details are for each company, but what we can do is prepare for anything by just understanding the science. So yes, there is some training that I do provide for individual companies and fleets and stuff, but it's more specific to their operations, what they're dealing with in particular. I can't just say, here's an EV, when they'll be like, wait a minute, you told me a battery pack was over here, but I see it over here. I don't care where the battery is. All I know is it has a battery. So my intention is to at least tell the people the physics, the theory behind it. So if I see a Rivian or a Tesla or whatever fly-by-night company comes by in the next month or two that has a product, we at least can recognize the physics are still the same. So yes, there is some training, but it's more specific to those applications that are more general. Lunchtime? Perfect.
Should we thank Ash for his presentation?